Why gravity is not a force. Right now, at this exact moment, something is accelerating you toward the center of the Earth. Not slowly, not gently, 9.8 meters per second. Every single second. Asterisk, here's the disturbing part. Nothing is touching you. No hands, no ropes, no invisible chains wrapped around your body. Yet you know with absolute certainty that if the floor beneath you vanished, you would fall. We give this feeling a name. Gravity. We say it's a force, a pull, a mysterious hand reaching out from nowhere. Something that pulls apples from trees, moons around planets, and you firmly onto the floor when the alarm clock screams. It feels obvious, unquestionable, almost boring. Drop your phone. It falls. Jump on the bed. You come crashing back. Stand on the roof of a tall building and look down. Your body doesn't wait for logic. It already knows the answer. Without something holding you, down you go. So, gravity must be a force, right? Except the moment you stop accepting the story everyone repeats and actually really look, the entire picture quietly begins to crack. Let me ask you an uncomfortable question. If gravity truly is a force, like magnetism, or the push of your hand on a door, then what carries it? Every force we understand has a messenger. Electromagnetism use light, tiny packets of energy flying back and forth. Inside atoms, other forces trade particles constantly. Even friction is just atoms smashing into other atoms. But gravity? What is touching you right now? Pulling you down? Close your eyes. Feel your weight. Is there wind blowing from above? A stream of invisible marbles hitting your head? A river of particles dragging your bones toward the ground? No. Absolutely nothing physical is touching you from above. And yet, you accelerate. Even sitting perfectly still, you are accelerating 9.8 meters per second squared toward the center of the Earth. That should feel deeply unsettling. Now rewind to the most innocent rule in all of physics. An object, with no forces acting on it, moves in a straight line at constant speed, forever. This isn't a rule we invented because it's convenient. It's the definition of times doing nothing. A straight line motion requires no explanation. Anything else does. So, when you drop a stone, and it curves toward the Earth, we instinctively say, aha, a force. But what if that conclusion is backwards? What if curved motion doesn't always mean a force is acting? What if sometimes the path itself is curved? Imagine something simple. You are an ant walking on a massive balloon. The balloon is slowly inflating. From the ant's perspective, it is walking straight ahead. No turning, no pushing, no sideways pull. But from far away, from a godlike viewpoint, the ant's path looks curved. Not because something is pulling the ant, but because the surface it walks on is curved. The ant feels no force, no invisible hand. Its world is simply shaped that way. Now, replace the balloon with space itself. Mass, Earth, the sun, you, me, bends the fabric of space-time. Objects, planets, are not being pulled. They are following the straightest possible paths, through a curved geometry. These paths have a name, geodesics, the space-time version of straight lines. Airplanes flying to New York don't follow straight lines on your flat map. They arc northward, sometimes passing near Greenland. On a map, the path looks wrong. But on the curved surface of Earth, it is the shortest, straightest route possible. No invisible force pulls the plane sideways. The geometry guides it. The same thing is happening to you as you fall toward Earth. Now consider the strangest thought experiment in physics. You are locked inside a completely sealed room. No windows, no phone, no outside information. Just you and a small red ball floating beside you. Case 1. The room is drifting peacefully through empty space. No engines. No nearby planets. The ball floats, weightless, silent. Case 2. The exact same room, but now it is falling freely toward Earth. From inside, everything feels identical. The ball floats. You float. You cannot tell whether you are floating in deep space or plunging toward a planet at thousands of kilometers per hour. Free fall feels like no force at all, because it is no force at all. Now, stand on the ground. Suddenly you feel heavy. Your feet ache after standing too long. Your spine compresses. Your muscles tense. That force is real, but it is not gravity. It is the ground pushing up on you. The floor is violently preventing you from following your natural path through space-time. It is accelerating you upward at 9.8 meters per second squared. Relative to free fall, that upward push is what you experience as weight. Flip the sentence. You do not feel gravity when you fall. You feel gravity only when something stops you from falling. Orbiting astronauts don't feel gravity. Not because gravity disappears, but because they are falling. Continuously, beautifully, missing the Earth every 90 minutes. They are in free fall. Weightless. Now let's add the part that makes your brain hurt. In the best possible way. Time. Clocks do not tick at the same rate everywhere. Atomic clocks on mountains run faster than clocks at sea level. Satellites must correct for this constantly, or your GPS would drift by kilometers every single day. A simple pulling force cannot slow time. No tug of war stretches seconds. But geometry can, because time is not separate from space. They are woven together into space-time. When mass curves space, it also curves time. Near heavy objects, time flows more slowly, like a river widening and slowing near a dam. A clock's path through space-time bends. Fewer ticks fit along that curved route. Near extreme curvature, things become even stranger. At the edge of a black hole, time appears to freeze for distant observers. An astronaut falling in seems to slow, redden, almost stop forever. But from her own perspective, nothing special happens. She crosses normally. Time feels fine. The geometry simply becomes extreme. You cannot shield gravity. You cannot block it with lead or cages, because you cannot block shape. Gravity is incredibly weak, far weaker than other forces, because it is not competing with them. It is the stage itself. All other forces act within a space-time. Gravity times is times space-time shape. So here we are. The apple is not being pulled by Earth. Both are sliding along the same curved valley in space-time. Your weight is not gravity dragging you down. It is the floor forcing you upward. The universe is not a machine of pushes and pulls. It is a landscape, a four-dimensional sculpture. Mass tells space-time how to curve. Space-time tells mass how to move. And the most astonishing part? We figured this out. Tiny creatures made mostly of water, living on a spinning rock, asking stubbornly simple questions. Refusing to accept that's just how it is. Doing thought experiments in our heads, while staring at the night sky. Once you see gravity this way, everything changes. You don't fight gravity when you climb stairs. You are resisting the natural curve of existence. You don't fall because something drags you. You fall because that is the path open to you. And the deepest question this leaves us with is not, how does gravity work? It is this. If we were so wrong about gravity for centuries, what else are we calling a force? That is really geometry in disguise? The story isn't finished. It's just beginning to become interesting. The universe isn't pulling you down. It is guiding you along the elegant folds of reality itself. And the fact that your mind can glimpse this, even for a moment, may be the most astonishing thing of all. So next time something falls, don't say, gravity pulled it. Smile quietly and think, asterisk, it's just following the shape of existence. Asterisk, asterisk. And maybe, just maybe, feel a little lighter. Number, why gravity is not a force. Chapter 2, Beyond Falling. What gravity really does to reality. So far, you've seen something unsettling. Gravity isn't a hand pulling objects down. It isn't a rope. It isn't a shove. It's the shape of space-time itself. But if that's true, if gravity is geometry, then an even stranger question appears. Why does everything fall the same way? Drop a feather and a hammer in a vacuum. They hit the ground together, no matter their mass, no matter their composition, no matter their internal structure. This shouldn't make sense. In every other interaction we know, objects respond differently. A magnet pulls iron, ignores wood. Fire melts wax, hardens clay. Wind tosses a leaf, but barely nudges a stone. Yet gravity treats everything equally. Not almost equally, exactly equally. That fact alone should make you suspicious. Think carefully. If gravity were a force like any other, it would need something to grab onto. Charge, mass, structure, something. But gravity doesn't care. An electron, a proton, a planet, a beam of light, all of them follow the same curved paths. Not because they are being pulled, but because there is no alternative path available to them. Here's a disturbing way to see it. Imagine you erase gravity entirely. Not weaken it, not reduce it. Erase it. What remains? Straight lines. Forever, objects would drift. Unaccelerated, unchanging, eternal. That's space-time with no curvature. Now add mass back in. Not as a force, but as a sculptor. Suddenly, the straightest paths are no longer straight in the Euclidean sense. They bend, not because something pushes objects sideways, but because straight itself has changed meaning. Asterisk, this is where intuition completely fails us. You were raised in a world where straight lines mean rulers, floors, walls, edges. But space-time doesn't obey those rules. It is not flat. It is not rigid. It flexes. And once you accept that, gravity stops looking like a mystery and starts looking inevitable. Now let's take this one step deeper. If gravity is geometry, then acceleration and gravity should be indistinguishable. And, disturbingly, they are... Picture this. You are inside a rocket, far from any stars. The engine fires. You feel pressed into the floor. Your feet hurt. Your spine compresses. Objects fall when you release them. Everything feels exactly like gravity, but there is no planet, no mass below you, only acceleration. Now reverse it. Stand on Earth. The ground presses into you. Your body strains. Objects fall. Everything feels exactly like acceleration, but you are not moving through space. Only space-time is curved beneath you. This equivalence is not coincidence. It is the clue. Acceleration and gravity are not siblings. They are the same thing seen from different angles. One is motion through curved space-time. The other is resistance against it. This realization destroys an old idea, that gravity acts on objects. Instead, objects act against gravity only when something prevents them from following their natural paths. Gravity doesn't cause falling. The absence of resistance does. Now, let's confront something even stranger. Light. Light has no mass. It cannot be pulled in the ordinary sense. And yet, light bends. Stars behind the sun appear shifted during eclipses. Galaxies warp the images of galaxies behind them, stretching them into arcs and rings, not because light feels a force, but because light follows space-time geometry too. Light doesn't curve because it's weak. It curves because there is no straight line left to follow. Pause here. This means gravity is not selective. It doesn't act more on heavy things and less on light ones. It reshapes the stage. And everything matter, energy, information must perform on that stage. And this leads to a profound consequence. Gravity controls causality. When space-time bends, it doesn't just bend motion. It bends what can influence what. What can affect what? What can reach what? This is why black holes exist. Not because gravity is strong, but because space-time curvature becomes so extreme that all future paths point inward. Once inside, there is no direction that leads out, not because of force, because out no longer exists as a direction in space-time. Inside a black hole, future points toward the center, the same way tomorrow points forward in time. Escape is not forbidden. It is meaningless. Now let's pull back, way back, to the universe itself. The universe is expanding, not objects moving through space, but space itself stretching. Distances grow, galaxies separate, and here's the crucial part. This expansion is not happening times inside times space-time. It is space-time. Gravity doesn't just curve space-time locally. It shapes the global fate of the cosmos. Will expansion continue forever? Will it slow? Will it reverse? Those are not questions about force. They are questions about geometry. Now notice something beautiful. Gravity is not trying to collapse the universe. It is not fighting expansion. It is simply expressing curvature in response to energy and mass. The universe evolves as geometry evolves, which leads us to an uncomfortable realization. If gravity is geometry, then space and time are not containers. They are actors. They respond. They change. They interact. This flips the old picture upside down. You are not moving through a static universe. The universe is dynamically reshaping itself. Around every movement you make, your path through space-time is not chosen afterward. It is defined simultaneously. And now comes the philosophical edge. If gravity is not a force, but the structure of reality itself, then asking why gravity exists is like asking why space exists, or why time exists. There may be no deeper answer, only structure. This is why gravity feels different from every other interaction. You can turn off electricity. You can shield radiation. You can isolate forces, but you cannot step outside geometry. You cannot opt out of space-time. Every thought you have, every word you read, every heartbeat you feel is a journey along a curved path in a four-dimensional landscape. And suddenly, falling stops being frightening. It becomes honest. You are not being dragged downward. You are following the only available route. Standing still, ironically, is the unnatural state. It requires resistance, effort, stress, motion, freefall, orbit. Those are the relaxed states. This is why astronauts float. This is why planets glide. This is why galaxies dance. Not because gravity commands them, but because geometry invites them. And now, one last unsettling thought before we continue. If gravity is geometry, then maybe, just maybe, the universe is not governed by forces at all. Maybe forces are approximations, shadows of geometry seen from limited perspectives. Maybe reality is not a machine. Maybe it is a shape, and we are not being pushed through it. We are being guided by its curves.